Nebulae, with their vivid colours and structures when viewed against the blackness of space, stand out as one of the most visually stunning sights in the universe. They can feature passionate reds, delicate pinks, regal purples and blues, such as those found in the Tarantula Nebula, or showcase blues and greens radiating out from the Snowball Nebula. And while colours enhance their visual appeal, they also offer scientists a wealth of essential information about the elements within the nebula. In this exploration, we will unravel the mysteries of nebulae, understand their types, characteristics, and what secrets the captivating colours reveal. Nebulae are vast clouds of gas and dust scattered throughout galaxies. Some spread hundreds of light years across, like the Eagle Nebula, home to the iconic Pillars of Creation, while others, such as the Little Ghost Nebula, in comparison are a mere light year across. They encapsulate the entirety of a star's life cycle, from the emergence of new stars within stellar nurseries, to the solemn repurposing of stellar material in the aftermath of a supernova explosion, where gravity can act as a sculptor, putting gas and dust together, whilst radiation from nearby stars shape the nebula's form. The Hourglass Nebula is one such structure where stellar winds generated by massive nearby stars have contributed to the dynamic evolution of this nebula. Emission nebulae emit light from ionized gases that have been energized by the influence of young stars. In stellar nurseries, like the North American Nebula, newborn stars emit intense ultraviolet radiation, transforming the surrounding hydrogen gas by ionizing its atoms as electrons are stripped away. When these liberated electrons reunite with ionized hydrogen, they release energy in the visible light spectrum, painting the nebula predominantly in reds and pinks, whilst elements like oxygen and sulfur present in the nebula contribute additional tones. The Orion Nebula beautifully exemplifies an emissions nebula, where red and pink hues from the ionized hydrogen are prevalent, with hints of blue and green from ionized oxygen and sulfur adding to the overall colour palette. The Pleiades Nebula is a beautiful reflection nebula that is bathed in a distinctive blue colour. Unlike Emission Nebulae, reflection nebulae do not emit light through ionisation, but rather shine by reflecting light from nearby stars. They do so through a process called Rayleigh scattering that emphasises shorter wavelengths of light, resulting in the bright blues we see. This scattering phenomenon is influenced by the size of the dust particles, which intensifies the blue tones the smaller the particles get, with specific shades of blue being further enhanced when hotter stars are nearby, as they emit light at the bluer end of the light spectrum. The Horsehead Nebula, situated in the Orion Molecular Cloud Complex, is a stellar nursery where new stars are born. However, its most distinctive feature is the silhouette of a horsehead, created by dense opaque dust blocking the light from background stars. Known as a dark nebula, this cosmic silhouette hints at the density of the dust within. Unlike nebulae that emit or reflect light, the contrast to dark nebulae is striking, as its high density of dust prevents visible light from penetrating through. Seeing through these dark nebulae can only be done when observed in infrared wavelengths, revealing hidden details and allowing astronomers to glimpse at the intricate shapes and structures within these nebulae. Billions of years into the future, our Sun will die. Its nuclear fuel will be spent as it enters the final phases of its life, when it will shed its outer layers, forming a planetary nebula in the process. The Helix Nebula, serving as a potential preview of this, showcases such an event where intense stellar winds have expelled material outward, creating a shell of ionized gas. The exposed central stellar core, now a white dwarf, radiates ultraviolet light, ionising the surrounding gas that triggers the emission of light, displaying a palette of greens and blues. These colours hint at the presence of ionised oxygen and nitrogen within the nebula, providing insights into the chemical composition of the expelled material and recounting the celestial history of this star. Messier 1, known as the Crab Nebula, is the remnant of a massive star having reached its end of life and gone supernova. What we see are shockwaves and ionised remnants of that spectacular explosion, where the immense energy released in the supernova's wake induces the surrounding interstellar medium to radiate vividly. Known as a supernova remnant, the Crab Nebula has an array of colours including red-orange, doubly ionised sulphur, blue, ionised iron, with dust appearing as yellow, white and green. In contrast to the reflective glimmers of reflection nebulae, or the vibrant nurseries of emission nebulae, supernova remnants like the Crab Nebula tell a different tale, one of a star's dramatic exit, leaving behind a vivid cosmic legacy. But regardless of the nebula type, one thing is certain. Through the cycle of ongoing creation within the stellar nurseries, and destruction of stars at the end of their life, nebulae put on one heck of a colourful show. Thank you for watching, and if you've liked the video then please consider leaving a thumbs up or maybe subscribe for more space related content from me, the Cosmic Skipper.